Hello students, in previous few videos we've done equation of tangent to ellipse and worked out some problems based on it. In this video we will take some very interesting properties of this tangent. Now we have here standard equation of ellipse a greater than b, so major axis will be x-axis. Equation of auxiliary circle will be x square plus y square is equal to a square. So here we have graph of ellipse with its auxiliary circle. Foci are f1 and f2. Coordinates of f1 are a comma 0. Coordinates of f2 are minus a comma 0. We have directrix x is equal to a upon e and x is equal to minus a upon e. These are standard things with this standard equation of ellipse. Okay. Now we have point P on the ellipse. Coordinates are a cos theta, b sin theta. P is variable point on the ellipse, so we consider coordinates in the form of parameter. Here theta is eccentric angle of point P. Okay. Now we have drawn tangent to ellipse at point P. Equation of this tangent is, we have standard equation, x upon a cos theta plus y upon b sin theta is equal to 1. Now let's start with the properties. We have this first property that fit of perpendiculars from foci upon any tangent lie on the auxiliary circle. Or we can say that locus of fit of perpendiculars from foci upon any tangent is auxiliary circle. Property is points m1 and m2 lie on the auxiliary circle. Let's prove this. To prove this, we use the locus concept. We will find the equation of locus of point m1, which is point of intersection of line f1 m1 and tangent to ellipse at point P. Now what will be equation of line f1 m1? This is perpendicular to tangent line. Okay, so its equation is x upon b sin theta minus y upon a cos theta equal to, now this line passes through focus f1 whose coordinates are a comma 0. For that here the constant term will be ae upon b multiplied by sin theta. Okay, an equation of line f2 m2 will be this minus a upon b sin theta. Together, let's consider this line f1 m1. M1 is point of intersection of this line and tangent line. Suppose coordinates of point M1 are h comma k. Okay. Now these coordinates satisfy this equation and equation of tangent. Okay. So we get h upon a cos theta plus k upon b sin theta is equal to 1 using equation of tangent, and from this equation we get h upon b sin theta minus k upon a cos theta is equal to a upon b sin theta. Now to get the equation of locus, we find a relation between variables h and k. For that, from these two equations we eliminate theta. We should eliminate theta. This is the strategy of getting equation of locus. अगर कुछ variables हैं हमारे पास तो हम उन variables को eliminate करते हैं to get the equation of locus. Now tell me, how can we eliminate theta? कैसे eliminate कर सकते हैं? Look at the terms of these two relations carefully. ध्यान से सोच के बताइए कि हम यहाँ पे क्या कर सकते हैं. We can square and add. By squaring and adding, we get h square plus k square multiplied by cos square theta upon a square plus sin square theta upon b square. Okay, and on RHS we get 1 plus a square e square upon b square multiplied by sin square theta. On LHS, the coefficient of h square and coefficient of k square are same. Coefficient will be this cos square theta upon a square plus sin square theta upon b square. Now what is our target? The equation of locus must be x square plus y square is equal to a square. That means we must get here h square plus k square is equal to a square. So for that, on RHS we take a square common. So inside bracket we have 1 upon a square plus e square upon b square sine square theta, and we get this equation if we prove that this is equal to this. अगर ये दो फैक्टर्स को इक्वल प्रूव करेंगे तो हमारा काम हो जाएगा. ठीक है, कैसे प्रूव कर सकते हैं? Here we have only sine theta. Okay, here we have cos theta, sine theta. So what we do? We write cos square theta as 1 minus sine square theta. ठीक है, simple approach है. So we have here, if you write cos square theta as 1 minus sine square theta, we get 1 upon a square plus sine square theta multiplied by 1 upon b square minus 1 upon a square. Take LCM here. We have in numerator a square minus b square, which is a square e square. For this ellipse, we have b square is equal to a square minus a square e square. So a square e square is a square minus b square. In numerator we have a square e square. In denominator we have a square b square. A square gets cancelled out. So we get here e square upon b square. Okay. So it is proved that these two factors are equal. We can cancel out this factor. We get h square plus k square is equal to a square. Then we replace h by x and k by y. We get equation of locus as x square plus y square is equal to a square, and this is equation of auxiliary circle. तो देखो यहाँ पे ये प्रॉपर्टी प्रूव हो गया. कॉन्सेप्ट हमने यहाँ पे लोकस का यूज किया, हमने पॉइंट m1 का लोकस निकाला जो ऑक्सिलरी सर्कल है. In parabola, fit of perpendiculars from focus upon any tangent lie on tangent at vertex. So here in the case of ellipse, auxiliary circle is equivalent to tangent at vertex to the parabola. ठीक है ना? Let's do next property. We have this property. Product of length of perpendiculars from foci upon any tangent is square of the semi-minor axis. इसको मैथमेटिकल इक्वेशन के फॉर्म में लिखते हैं. Now here we have this ellipse. Okay, A is greater than B, so semi-minor axis is B. So according to this property and from this diagram, we must have f1 m1 multiplied by f2 m2 is equal to b square. Product of length of perpendiculars from foci f1 and f2 is square of semi-minor axis, and here it is b. So this product is b square. Let's prove this. We can simply get f1 m1 and f2 m2. Distance of focus f1 from tangent line is e cos theta minus 1. This is inside modulus. Okay, upon root cos square theta upon a square plus sine square theta upon b square. Multiply by what is f2 m2? It is minus e cos theta. Distance of point f2 from tangent line is minus e cos theta minus 1. This is inside modulus upon square root of cos square theta upon a square plus sine square theta upon b square. Okay. Now we have to prove that this product is b square. It's simple. Now this is 1 plus e cos theta when we remove modulus function, and this will be 1 minus e cos theta because e cos theta is less than 1. So when we remove modulus function, we have here 1 minus e square cos square theta, and in denominator we have cos square theta upon a square plus sine square theta upon b square. This is equal to b square. So what we do? We multiply numerator and denominator by b square. We get b square multiplied by 1 minus e square cos square theta upon b square upon a square. What is b square upon a square? It is 1 minus e square from here. Okay, so we have 1 minus e square cos square theta plus sin square theta. We are multiplying denominator by b square, so here b square gets cancelled out. So we have here sin square theta. Now cos square theta plus sin square theta is 1. So in denominator we have 1 minus e square cos square theta. This factor gets cancelled out. So we get here b square. ठीक है, हमें यहाँ पे b square मिलेगा ना. So this is proof that product of length of perpendiculars from foci upon any tangent to this ellipse is b square. In general, this product is square of semi-minor axis. ठीक है ना? Let's try some questions based on this property. Like here we have this question for ellipse x square over 25 plus y square over 16 is equal to 1. Prove that f1 m1 plus f2 m2 is greater than or equal to 8. Okay, now we have this value f1 m1 multiplied by f2 m2. This is equal to b square. Here b square is 16. Okay, so this product is 16. We have value of this product. Okay, then we have to prove that sum of these two values is greater than or equal to 8. क्या आइडिया आ रहा है यहाँ पे? मैथमेटिक्स का कौन सा कॉन्सेप्ट यूज कर सकते हैं? यहाँ पे दो वैल्यूज का सम है, ठीक है, और यहाँ पे उन दो वैल्यूज का प्रोडक्ट है. बोथ दिस वैल्यूज आर पॉजिटिव. वी कैन यूज इनइक्वालिटी arithmetic mean greater than or equal to geometric mean for the values or quantities f1 m1 and f2 m2. Using this, we have f1 m1 plus f2 m2 upon 2. This is greater than or equal to f1 m1 multiplied by f2 m2 power 1 upon 2. Okay. This value is 16. 16 square root is 4. Okay. So this side is 4. Take 2 on RHS. We get f1 m1 plus f2 m2 greater than or equal to 8. Okay, now here the least value of this sum is 8, and this occurs when f1 m1 is equal to f2 m2. We have am is equal to gm when the quantities involved are equal. तो यहाँ पे जब f1 m1 f2 m2 इक्वल होंगे उस टाइम पे ये सम अपना लीस्ट वैल्यू अज्यूम करेगा, एंड लीस्ट वैल्यू इज 8. एंड when we have f1 m1 is equal to f2 m2, this is for tangent at extremity of the minor axis. अगर हम minor axis के extremity पे tangent draw करेंगे तो ये tangent major axis को parallel हो जाएगा. This tangent is parallel to major axis. In that case, we have f1 m1 is equal to f2 m2 is equal to 4. Each value is semi-minor axis. ठीक है ना? Okay, let's take one more question on this property. Okay, now we have this very interesting question based on this property. Question is, an ellipse with major axis 2a and minor axis 2b touches the coordinate axis in the first quadrant. If the foci are x1, y1 and x2, y2, then prove that x1, x2 is equal to b square and y1, y2 is also b square. Here we have variable ellipse with major axis 2a and minor axis 2b. This ellipse touches both the coordinate axis. It lies in the first quadrant. Okay, so we have this figure. We have coordinate axis. Ellipse lies in first quadrant touching both the axis. In fact, ellipse slides between the axis. Ellipse जो है वो दोनों एक्सिस को फर्स्ट क्वाड्रेंट में टच कर रहा है और उसके बीच में स्लाइड हो रहा है. Foci are f1 and f2. Coordinates of f1 are x1, y1. Those of f2 are x2, y2. We have to prove that x1, x2 is equal to b square. कैसे प्रूव कर सकते हैं? Now x1 and x2 are lengths of perpendicular from foci upon y-axis, and y-axis is one of the tangents. Okay, so according to this property, we have product of lengths of perpendiculars upon any tangent line is b square. square of semi-minor axis. Here tangent line is y-axis. Similarly, y1 and y2 are lengths of perpendiculars from foci upon x-axis. So this product is also b square. This product is square of सेमी माइनर एक्सिस. ठीक है ना. तो एक सिंपल ऑब्जर्वेशन बेस्ड क्वेश्चन है. तो अगर आपको ये प्रॉपर्टी पता है तो आप ये क्वेश्चन बहुत आसानी से कर सकते हैं. ओके, नाउ वी हैव दिस प्रॉपर्टी. Length of tangent between the point of contact and the point where it meets the directrix subtends right angle at the corresponding focus. Here in the figure, tangent to ellipse at point P meets directrix x is equal to a upon e at point Q1 and directrix x is equal to minus a upon e at point Q2. Now, according to this property, length PQ1 will subtend right angle at focus F1 and length PQ2 will subtend right angle at focus F2. Let's prove this. Let's consider this directrix and this focus. PQ1 will subtend right angle at focus F1. Prove करते हैं. कैसे prove कर सकते हैं? Here lines PF1 and F1Q1 will be perpendicular, and when two lines are perpendicular, product of their slopes will be -1. Okay. So what do? We get the slopes of lines PF1 and F1Q1. For that we must have coordinates of point Q1. At Q1 directrix and tangent intersect. Then what will be coordinates? Abscissa of point Q1 is A upon E. Okay. And how we get ordinate? To get the ordinate, what we do? We solve a tangent line with the directrix. In the equation of tangent, we put x is equal to a upon e. We get cos theta upon e plus y upon b sine theta is equal to 1. From this we get the value of y or ordinate of point q1. क्या होगा ordinate? Ordinate will be b upon sine theta multiplied by 1 minus cos theta upon e. So we have here coordinates of point q1. Now our target is slope of pf1 multiplied by slope of f1 q1 is -1. हमें प्रूव करना है कि इन दो लाइंस का जो स्लोप्स है उसका प्रोडक्ट -1 है. स्लोप ऑफ pf1 is b sin theta upon a cos theta minus a, and slope of f1 q1 will be, क्या होगा स्लोप? b upon sin theta multiplied by e minus cos theta upon e. ओके, तो e हम यहाँ पे लिखेंगे डिनोमिनेटर में, मल्टीप्लाई बाय a अपॉन e माइनस a. ठीक है ना. प्रूव करना है कि ये -1 है, जो सिंपल है. हियर sin theta gets cancelled out. Okay, from this we have a common, so e minus cos theta gets cancelled out, leaving minus a here. Okay, multiply e inside this bracket, we have a minus a square. Okay, so from this we have now minus b square upon a square multiplied by 1 minus e square. B square upon a square is 1 minus e square. So this is equal to -1. So it is proved that length PQ1 subtends right angle at corresponding focus F1. Similarly, we can prove that length PQ2 subtends right angle at focus F2. ठीक है ना? We had same property in the parabola and we will have same property in the hyperbola also. Okay, now we have this common property for all the conic sections. The property is tangents at the extremities of Latus rectum pass through the foot of directrix on the major axis. Now here in the figure, directrix x is equal to a upon e meets x-axis or major axis at point C1 having coordinates a upon e comma 0, and directrix x is equal to minus a upon e meets x-axis or major axis at point C2 whose coordinates are minus a upon e comma 0. Okay. Now in ellipse we have two lattice rectum lines. Lattice rectum line is a line passing through focus and perpendicular to major axis. Now here in the figure, lattice rectum line through focus F1 meets ellipse at points A1 and B1, and lattice rectum line through focus F2 meets ellipse at points A2 and B2. Now we draw tangents to ellipse at points A1 and B1. The property is these tangent lines pass through point C1. C1 is foot of directrix on the major axis. And here tangents to ellipse at points A2 and B2 pass through point C2. ये हमें प्रूव करना है. Okay, now what are the coordinates of extremities of lattice rectum? Like what are the coordinates of point A1? It is extremity of lattice rectum in the first quadrant. क्या होंगे point A1 के coordinates? Coordinates are AE comma B square upon A. Okay. Now what do we do? We get the equation of tangent to ellipse at this point. We can use this equation x1 upon A square plus y1 upon B square is equal to 1. Replace x1 by A and replace y1 by B square upon A. We get equation of tangent as x AE upon A square plus y multiplied by B square upon A. This upon B square, this sum is equal to 1. This is equation of tangent to ellipse at point A1. अब हमें प्रूव करना है कि ये जो टेंजेंट लाइन है वो पॉइंट C1 से पास हो रही है. तो क्या करेंगे, हम पॉइंट C1 के कोऑर्डिनेट्स को इस इक्वेशन में रखेंगे और चेक करेंगे कि क्या ये कोऑर्डिनेट्स इसको सेटिस्फाई कर रहे हैं या नहीं. डेफिनेटली करेंगे सेटिस्फाई इसको, ठीक है ना. x को यहाँ पे रखेंगे हम a upon e, put x is equal to a upon e, okay, and put y is equal to 0, and certainly this is 1. That means point C1 satisfy this equation. So this property is proved. What is the property? Tangents at the extremities of lattice rectum pass through the foot of directrix on the major axis. Okay, right? Let's take one more common property which is for all the conic sections. We have this property, chord of contact with respect to any point on the directrix passes through the corresponding focus. Here we have point R on the directrix, x is equal to a upon e. From this point we draw tangents to ellipse. We join the points of contact. Now this chord of contact passes through focus F1. Here F1 is a corresponding focus to directrix, x is equal to a upon e. This is the property. Let's prove this. Now, what is the equation of chord of contact? We know how to get the equation of chord of contact. Equation is t is equal to 0. What is structure of this equation? We replace x square by xx1, y square by yy1, where x1, y1 are coordinates of point through which tangents are drawn. Now, here we have point R in consideration. What will be coordinates of point R? क्या होंगे point R के coordinates? Coordinates will be a upon e comma y1. Abscissa is fixed, a upon e. Coordinate is variable. Okay, here y1 is variable. So equation of chord of contact to ellipse with respect to this point will be x multiplied by a upon e over a square plus y1 over b square is equal to 1. Now chord of contact passes through focus F1 if point F1 satisfies this equation. So we put the coordinates of point F1 in this equation. We have a E multiply by A upon E over A square plus 0 is equal to 1, and certainly this value is 1. That means focus F1 satisfies this equation. That means chord of contact passes through focus F1. ठीक है ना? Here y1 is variable. For all possible values of y1, chord of contact passes through focus F1. So this property is proved. And if we take a point on directrix x is equal to minus a upon e, then chord of contact corresponding to this point will pass through focus F2. Here F2 is focus corresponding to this directrix. ठीक है ना? Okay, now we have one very interesting property of tangent which defines the reflection property of ellipse. The property is tangent to ellipse at point P bisects the external angle between focal radii PF1 and PF2. That means tangent is one of the angle bisectors of lines or focal radii PF1 and PF2. The another angle bisector will be normal. कैसे प्रूव करेंगे ये प्रॉपर्टी? Now slope of tangent is, tangent का slope क्या होगा? माइनस बी कॉस थीटा अपॉन ए साइन थीटा. ओके, स्लोप ऑफ पी एफ वन, सपोज स्लोप m1 है, तो क्या होगा पी एफ वन का स्लोप? स्लोप विल बी बी साइन थीटा अपॉन a cos theta minus e, and slope of line pf2, say m2, this is b sin theta upon a cos theta plus a. Okay, now we will have some calculations. Okay, we can prove that modulus of m1 minus mt over 1 plus m1 mt. Okay, this is tangent of angle between pf1 and tangent line. This is equal to modulus of m2 minus mt over 1 plus m2 mt. This is tangent of angle between line pf2 and tangent line. Okay, we can easily prove that these two values are equal and each value is modulus of b upon ae sin theta. Okay? That means angle between pf1 and tangent line is equal to angle between pf2 and tangent line. That means tangent bisects the external angle between focal radii pf1 and pf2. ठीक है ना? यहाँ पे जो ये कैलकुलेशन पार्ट है वो आप खुद ट्राई करें. टारगेट क्या है? ये दोनों वैल्यूज मॉड्यूलस ऑफ बी अपॉन ए साइन थीटा होंगी. Now from this we can define reflection property of ellipse, like if incident ray is sent along line PF1, okay, then after striking the surface of ellipse, reflected ray passes through the another focus. Reflected ray travels along line PF2. अगर इंसिडेंट रे PF1 के अलॉन्ग है तो इंसिडेंट रे इलिप्स से स्ट्राइक होने के बाद फोकस F2 से पास होगा. ठीक है ना? अगर हम लाइट का सोर्स रखते हैं F1 के ऊपर तो जो लाइट रेस एमिट होंगी वो रेस इलिप्स की सरफेस से रिफ्लेक्ट होके फोकस F2 से पास होंगी. दिस इज द रिफ्लेक्शन प्रॉपर्टी. ओके, also here we can say that reflection of point F1 in the tangent lies on the line PF2. Point F1 का tangent line में जो reflection है वो किस line के ऊपर होगा? वो line PF2 के ऊपर होगा. ठीक है ना? In this figure, point S is reflection or image of focus F1 in the tangent line. Point S will lie on line PF2. Point S जो है वो line PF2 के ऊपर होगा. हम PF2 को एक्सटेंड करेंगे तो S पॉइंट जो है वो इस लाइन के ऊपर होगा. Now we have very interesting questions based on this property. Okay, let's try this question. Ellipse has foci 1 comma minus 1 and 2 comma minus 1, and equation of one of the tangents is x plus y minus 5 is equal to 0. Then we have to find the point where this line touches the ellipse. Ellipse के foci के coordinates given है, एक टेंजेंट का इक्वेशन गिवन है, हमें पॉइंट ऑफ कांटेक्ट निकालना है जहां पे टेंजेंट इलिप्स को टच करेगा. So we consider this figure only. This is not the graph of ellipse x square over a square plus y square over b square is equal to 1. ठीक है, बट स्ट्रक्चरल एस्पेक्ट्स तो सारे वही रहेंगे. Properties do not change with the equation of ellipse. Okay. Now foci are 1 comma minus 1 and 2 comma minus 1. Point f1 has coordinates 2 comma minus 1 and f2 has coordinates 1 comma minus 1. Now point S is reflection of focus f1 in the tangent line. This line touches the ellipse at point P. Equation है इस line का x plus y minus 5 is equal to 0. Point S is reflection of f1 in this tangent line. Now here, according to the property, point S lies on line PF2. Okay, so we can say that point P is point of intersection of line F2S and tangent line. Point P जो है वो tangent line and line PF2 या F2S का point of intersection है. टेंजेंट लाइन का इक्वेशन तो हमारे पास है. देखिए, तो हम क्या करेंगे, हम लाइन PF2 का इक्वेशन निकालेंगे. हाउ वी गेट द कोऑर्डिनेट्स ऑफ रिफ्लेक्शन पॉइंट? वी हैव फॉर्मूला. इफ रिफ्लेक्शन ऑफ point x1 comma y1 in the line ax plus by plus c is equal to 0 is x2 comma y2, then we have x2 minus x1 upon a is equal to y2 minus y1 upon b is equal to minus 2 multiplied by inside bracket ax1 plus by1 plus c upon a square plus b square. Okay. Now using this formula we can get coordinates of point S. Suppose coordinates of S are x2 comma y2, then we have x2 minus 2 upon a. Here a is coefficient of x. We are considering this equation. Okay, this is equal to y2 plus 1 upon coefficient of y, which is 1. This is equal to minus 2 multiplied by, we put coordinates of focus f1 in this expression. We have 2 minus 1 minus 5 upon a square plus b square, which is 2. 2 gets cancelled out. This is minus 4. Okay, minus 4 multiplied by minus 1, 4. Okay, so we get x2 is equal to 6 and y2 is equal to 3. So coordinates point S are 6, 3. ठीक है ना, हमारे पास point S के coordinates आ गए. Now we can get equation of line PF2 or F2S. क्या होगा equation? Slope of line will be 3 plus 1 upon 6 minus 1 is equal to 4 upon 5. So equation of line F2S will be 4x minus 5y minus 9 is equal to 0. Now point P is point of intersection of these two lines. Okay, we solve these two equations, we get point of intersection as 34 upon 9 comma 11 upon 9. Okay, so we have point of contact on the ellipse where this line touches the ellipse. तो इस प्रॉपर्टी को यूज करके हम इस तरह के क्वेश्चंस बना सकते हैं, सॉल्व कर सकते हैं.